Hi, I'm Michael from St Peter's College in Auckland, and Rachel's discussion around pies has reminded me that I like pies. So I'm, yes, Dr Michael Harvey from St Peter's College in Auckland, dream weaver and visionary, and my discussion is on light and time and illuminating relationship. So nearly 100 years ago, Einstein developed the theory of relativity. This theory states that nothing can travel faster than light. Recently, however, after discovering this from my Year 7s, researchers have discovered that light can travel 300 times faster than expected. But don't panic, the devil is in the detail. So, in a vacuum, light travels at about 300,000 kilometers per second. Now, according to the theory of relativity of Einstein, this is the speed limit for the universe from spacecraft to subatomic particles. Anything which contains an information or causes an effect has this speed limit. So in terms of slowing things down, try throwing a stone into a pond. See, pond, just placing it out there for you there, Paula, to make ripples. Look at a particular wave and it will appear to move quickly, but then take a wider view to the group of waves from this animation, and they travel outwards from the point of where the stone hits the water slowly. You can watch as new ripples rise at the back of the wave group, whiz forward and fade away to the front. Now the same thing happens with light. As a light wave interacts with atoms, this creates outgoing ripples of light waves. When these ripples overlap and combine with the first wave, they remove the waves racing on ahead, reducing the fast-moving wave front and slowing down the group of waves. So from this animation, the light passes through matter has two special speeds, that of the group of waves and that of the individual wave, known as the phase velocity. So, what happens? Well, dense matter reduces the group velocity of light to below that of the phase velocity, causing something called refraction, the effect that causes a straw to look bent when it is stuck in water. So can the situation be reversed? The ripples of light actually make the wave group travel faster than the phase velocity. So, can you do this? Well, you can give energy to atoms with something called a laser. So energized, the atoms increase the velocity of the wave group, and this causes the group velocity to become negative, which means that the laser pulse appears to exit the gas before it enters. In other words, light waves seem to run backwards. So, great Scott, is time travel a possibility, Marty? Well, the theory of relativity predicts that speed slows time. And it also predicts that if a particle could exceed the speed of light, then the time difference would be negative, and the particle could effectively travel back in time. So, what are the consequences? Well, for any Doctor Who fans out there, travel creates problems. For example, suppose a faster-than-light particle is used as a signal to explode a bomb in the very lab that the particle itself was created. If the bomb explodes yesterday, the particle cannot be made today, so things get weird. So it's all down to the timing of the laser pulse. Timing the speed of the laser beam pulse is difficult, as the shape of the pulse changes when it passes through matter. To make a pulse of short time involves mixing waves of different frequencies, and with matter, each wave will spread differently. So, is there a solution? Well, the problem is related to the quantum nature of light, where light waves are made of photons that act like particles. Photons, of course, are subject, therefore, to Heisenberg's uncertainty principle. So, it isn't possible to pick out a given component photon, and observe it traveling faster than the speed of light. So, effect still follows cause.